Hello, good evening, all of you. Audio video clear? Please mention whether the audio video is clear. Yes, so welcome back after 2 days. Hope all of you are enjoying this course and so glad to see that last lecture, Jasse's session, all of you liked the comments we received after the class was overwhelming. So we will try to give more quality content in the future. So keep supporting us, all of you, and please invite more and more people to this session. Share this link and let more people join. To the new students, this is a series where we are learning general aptitude section concepts in detail, detailed theory of each of the topics, and definitely this will be useful for other exams also where these topics are there, like GATE exam or any other exams where these topics are also there. GATE exam non-verbal ability and CSIR aptitude section is more or less the same itself. Okay, so for the new students, if you want to be part of the Telegram channel or WhatsApp group, this is how you can be part of the Telegram channel or WhatsApp group. In the description of this video also, you can get the links of how to be part of this Telegram channel, WhatsApp group, and other free resources we are providing. In the Telegram channel, we are running daily quizzes, and weekly we are conducting a live quiz also. So make use of all those free resources. Check out the description of this video. You will get all those resources. Paid courses, Bhavana, as of now it is not there, but in the future we will be starting, say in 1 or 2 months, you can see paid courses in the mobile application Christy's classes, you can see, or when you subscribe this YouTube channel, you will get updates of all our upcoming courses, upcoming projects, all of it you will get update through this YouTube channel itself. So hit the bell icon so that you will get update of all the updates we are giving, and also the community posts also you can check out where we post updates of upcoming projects. Okay, so as we daily say, you can check out these courses also along with this course to learn previous year questions and other extra questions. You can check out the extra courses given in the profile, especially this course CSIR-NET General Aptitude full course. CSIR-NET General Aptitude full course is available that you can check out to get more practice of more questions. This is the course I am mentioning about, CSIR-NET General Aptitude full course. And for GATE also full course we have given. We have tried our maximum to give maximum content free of cost itself through this channel. So make use of those resources and please spread the word. Let more people get to know about it, and that will inspire us definitely to give more free courses in the future. Okay, so let us start. And printed material, those of you want printed material, this is the bestseller book for part A section available in Amazon and Flipkart. So you can search this title and you can find the book in Amazon and Flipkart. So more about the course we have discussed already in the previous classes. So without wasting more time, we will directly go to today's topic. Divisibility is today's topic. Last class you will heard about types of numbers. Now using those numbers, we will see few concepts related to divisibility, and the idea of remainder also you are familiar with. Okay, so first of all, let us start from very basic things. In school days, what you have learned about divisibility or what is division? Let us start from there. What is division? Let us try to learn like very basic stuff itself. Even if you know them, let us try to understand it so that maths will become more interesting day by day. Things that we understood also sometimes we don't remember, or we don't recollect it. So let us understand division properly and then we will go to divisibility. What is division? All of you know. For example, when you divide 60 by 10, 60 by 10, that is like 60 mangoes you are dividing among 10 people. If 60 mangoes are there and 10 people are there, everyone will get how many mangoes? Everyone will get 6 mangoes now. And that is division. So that is nothing but repeated addition itself. 60 divided by 10 means how many 10s will make a 60? That means 10 plus 10 plus 10 plus 10 plus 10 plus 10. 6 times added, you will get 60. So how many 10s should be repeatedly added? In the last class, Justice sir mentioned about multiplication is repetitive addition. Na? Same way, division is also nothing but repetitive addition expressed in a different way. So 60 by 10 means how many 10s will make a 60? That is 6 10s will make a 60. But if it is like 60 chocolates, you need to give to 20 people. Everyone will get 3 chocolates only, because 3 chocolate, 3 chocolate, 3 chocolate 20 times 3 into 20 is 60. 3 into 20 is 60. If it is 60 chocolates divided among 30 people, everyone will get 2 chocolates each. That is 2 30s will make a 60. 30 plus 30 is 60. 30 plus 30 is 60. That is what is called 60 by 30 equal to 2. And if 60 chocolates are given among 60 people, everyone will get 1 chocolate each now. So there is actually an anecdote related to Srinivasa Ramanujan, as you all know, the famous mathematician, or the man who knew infinity, right? So the man who knew infinity, Srinivasa Ramanujan, in his, it is told that this is a story that happened in his life, that when a teacher was asking, telling about division, teacher was telling some example like this: bananas, 12 bananas divided among 12 people, how many bananas everyone will get? 12 bananas divided among 6 people, how many bananas everyone will get? 12 bananas divided among 4 people, how many bananas will everyone get? So in an interesting way, the teacher was explaining that. And 12 bananas divided among 1 person, how many bananas everyone will get? So everyone understood division by that, but Srinivasa Ramanujan was not satisfied completely. Srinivasa Ramanujan suddenly asked, what if 12 bananas are divided among no people at all? 12 bananas divided among 0 people, that is division by 0. That is why later, Srinivasa Ramanujan was very interested in infinity. That is why many theorems or many infinity is a topic that we need to discuss on a separate day. One lecture for infinity or maybe 10 lecture for infinity is possible. So anyway, Srinivasa Ramanujan was asking, if 12 bananas divided among 0 people, everyone will get how many bananas each? So his friends was laughing, what a question, 0 people means how the division? Yeah, that is what we call not defined. Division is not defined. That we will discuss on another day about infinity. If you people are interested, do comment if you want to learn more about infinity, pi, e, etc. Those are some interesting stuffs which will actually ignite your interest to learn maths further. Many people feel that math is boring, but so happy to see after starting this course, many comments we can see in the chat or see in the comment section also, that you started liking maths. Even those students who feared maths and skipped the subject which is having maths in it. Okay, anyway, so the division you should all actually understand in this way. Okay, all of you, this course we will continue in English only. Other languages we will try to add subtitle. We are working on it. If possible, we will add it very soon. But we are using very simple English so that you can understand. And study materials and other stuff will compensate if in case you are not understanding anything or something. Check the study material and other videos in the platform also. By that you can easily pick up the things that you missed from the session in case. Okay, yeah, many people are interested about learning about infinity, na? Definitely we will discuss. Yeah, last class Justice sir also was mentioning about the small infinity, big infinity concept. That also, as I told, infinity is a separate topic that we can continue for many lectures actually. Okay, coming back to, so that is how you have to see division. Division, if you understood it practically like this, then it is very easy. Now come the situation, what if 62 mangoes or 62 chocolates are divided among 6 people? So we can think like, if there are 6 people, A, B, C, D, E, F, everyone will get 10 chocolates or 10 mangoes each. After that, there will be 2 mangoes remaining. That is what is called remainder. So considering the remainder also, we can actually write division algorithm. What is division algorithm? Dividend is equal to divisor into quotient plus remainder. Yeah, I know that some of you may have forgotten which is divisor, which is dividend. Like the terms can be confusing. Dividend and divisor getting confused with each other. That is all fine. But the concept you should understand, that is more important. So as I told, 62 is 62 divided by 6, quotient is 6 and remainder, sorry, quotient is 10 and remainder is 2 means how many 6's will make us 62? 10 6's will make 62, but after that there will be 2 chocolates remaining. That is the meaning of that division. So 10 6's will make us 62. So 10 into 6, 60. And then what is remaining? 2. So divisor into quotient. Yeah, here actually it is divided by 10. It can be reversed also. 6 into 10 plus 2 also you can tell. Here I have told division by 6. So the divisor was 6 here. The quotient was 10 here. And remainder is 2. All of you clear? This much is clear or not? Again, these are things you already know, but I am trying to give it a practical reference so that when you see a question also, it will be interesting to try them. Then you should definitely know about prime factorization. I hope all of you remember prime factorization, isn't it? Prime factorization idea. Yeah, all of you remember it, right? Like if 60 itself, 60 when you divide by, first you divide by the smallest prime number, that is 2, 60 by 2, 30, 30 by 2, 15, 15 by 2, 15 by 2 you cannot do, so you divide by 3. Divide by 3, that is 5. 5 by 5 is 1. So, and this expression 2 into 2 into 3 into 5 is called prime factorization. So, that idea you should know. At least in few questions you may need this prime factorization idea. As I told, in this class we are trying to concentrate on the most important things you need for doing questions. So then what are factors, multiples? I hope all of you know what is factor and what is multiple. 5 is a factor of 30 means that division idea itself. 30 divided by 5 is 6. That means 5 if you divide, you will not get a remainder. You will get 0 as the remainder. No remainder means that is a factor. Yeah, last class Jessica was giving a very good example of arranging the chairs. That idea you can use here actually. For 30, how many factors are there? Factors always occur in pairs. Factors always occur in pairs. Like 1 and 30 are factors. Why? 1 into 30 is 30. Yeah, here do you remember? 10 into 6 plus 2 also you can write. 6 into 10 plus 2 also you can write. Because if 10 is a factor, 6 is also a factor and vice versa. Clear? So here actually, yeah, we are discussing about without any remainder. So 60 example you take. 10 into 6, if that is possible, 6 into 10 is also possible. So 30, 1 and 30 are factors because 1 into 30 is 30. 2 and 15 are factors because 2 into 15 is 30. 3 and 10 are factors because 3 into 10 is 30. Then what? 5 and 6 are factors because 5 into 6 are 30. So these are the factors of 30. And 30 is the common multiple of all these factors. 1, 2, 3, 5, 6, 10, 15, 30. 30 is the common multiple. So that is multiple. So the chair idea you can actually understand here. 30 people or 30 chairs are to be arranged. So 2 and 15 is a pair means you can actually arrange 15 chairs in a row. 15 chairs in a row. Likewise, 2 rows are needed. So the column number and row number are actually factors in this case. All of you clear? Those of you missed the previous session, please check that. That is a very interesting session and that concept you can use here also. Is it clear, all of you? So you can make a rectangle like this, or you can make a rectangle like 15 into 2 rectangle also is possible. 2 into 15 is 30, 15 into 2 is 30. Likewise, each other pairs you can actually write like this. Then what about say 9? What are the factors of 9? 1 and 9 are factors. Then 3 is the next factor. But I told factors always come in pair. But where is the pair of 3? Yeah, the pair of 3 is 3 into 3 is 9. But 3 and 3 are not distinct numbers. That is why we write only 1 times 3. And that concept again you can actually do with 333. Likewise, you can make a 9. The chair arranging idea we discussed in the last class, that idea can be used. So you will form a square actually. Instead of a rectangle, you will form a square there. You will form a square there. All of you clear? Iqbal, which part you have doubt? Why 2 row? You can take 2 row as an example, I told Ria. Not only 2 row, you can take 3 row, then 10 columns are needed. If last class is missed, please check that session. That is where we discuss this concept. If it is 1 row, 30 columns are needed, or 30 row, 1 column is needed. Is it clear now, all of you? So always connect with practical examples, then math will be easy. CSIR-NET Part A section will be definitely easy. Before going to test of divisibility, I will show you 1 or 2 questions super fast, or 1 question super fast, which was asked in a very recent CSIR-NET exam. So can you try this question? Very fast, can you try this question? All of you. And once again, those of you feel that this session is useful, do hit the like button and do comment on this video after the session. That will help YouTube to recommend this video to maximum people. That is one way YouTube algorithm works, to recommend good content to more people. So if you think the session is useful for more people, then only hit the like button. Otherwise, no need to do anything. So doubt in 2 row. Doubt in 2 row means Iqbal, 30 you can divide as 2 into 30 by 2 is 15, or 30 by 15 is 2. No reminder. That means 15 and 2 are factors. Nah? 15 and 2 are factors. 15 and 2 are factors means 15 chairs, 2 rows. 15 into 2, 30. You can write that. Nah? Because 15 chairs in the first row, 15 chairs in the second row. Again, the analogy of chairs I am taking from the previous class. Those of you missed the previous class, please check out that video. Poll won't be there, Diksha, but we will try if we can add some Menti quiz or something. Some of you got an answer, very good. How many integers in the set 1, 2, 3, 4 up to 100 have an odd number of divisors? Divisor means factor itself. Factor and divisor are the same, na? Odd number of divisors. But there are 100 numbers from 1, 2, 3 up to 100, na? 100 numbers, how you will check all of them? No, you should not check. An important aspect in maths is identifying patterns. You should identify patterns here. How you can identify patterns here? Check 2-3 numbers at least. What are the factors of 1? Only factor of 1 is 1. What are the factors of 2? 1 and 2 are the factors of 2. What are the factors of 3? 1 and 3 are factors of 3. So for prime numbers, there will be 2 factors exactly. In the last class also it was mentioned, right? That prime numbers have exactly 2 factors. The prime numbers have 2 factors. So odd number of factors means 2 is not odd number of factors. So all the prime numbers can be avoided from this list. Prime number will not be the answer. It will be composite numbers which have odd number of divisors. Okay, just clarifying, in the study material also, after the session, just as I have provided the study material, there it was mentioned 1 is neither prime nor composite. 1 is not prime also, not composite also. So what about 1? How many factors? 1 divisor or 1 factor only? 1 factor only. 1 factor only means odd number of factor. Na? So 1 is such a number. 1 is such a number Then the next such number is 4. 4 is the next composite number. Na? 4 have 1 and 4 as factors. 1 into 4 is 4. Na? I told you factors occur in pair. Also 2 into 2 is 4. So that pair you take only one number. The pair means even number. Then one number. Even plus odd is odd. Last class you have learned that. Na? Even plus odd is odd. So as even plus odd is odd, pairs means even number plus one more number, that will be odd. 4 have such a speciality. Which other numbers will have such a speciality? Those numbers whose factors are like x into x is the number. Those kinds of numbers are called perfect squares. Now, don't by heart it. Understand the concept. For perfect squares, there will be odd number of factors because after pairing you will get finally one number whose pairing is with the same number itself. That means only one time you will write it. For example, 9, 1, 9. Then 3 is the third factor. That will make three factors or 3 divisors. That is odd number. 16 also, 1 and 16. Then 2 and 8. 2 into 8 is 16. Now. Then 4 into 4 is 16. So 4, that makes 5 factors. Is it clear all of you? 5 factors. How 5 factors? And did you understood for perfect squares why this will work all the time? And only for perfect square this will work. Odd number of factors are only for perfect squares. So 1, 2, 3 up to 100, how many numbers have odd number of factors? This question can be rephrased as how many integers in the set 1, 2, 3 up to 100 are perfect squares? Perfect squares are 1 square, 2 square, 3 square, 4 square up to 10 square. Na? So 10 numbers for sure. All of you understood? This was a latest CSIR-NET problem which asked in the last year. Clear? And believe me, this was in one set of one subject question paper. Same type another question was another type question, another subject question paper. That is what I want to reiterate. CSIR-NET Part A section is common for life science, mathematical science, physical science, chemical science and earth science. You can take previous year question papers of all these subjects to practice because every science subject have the same Part A section itself. If exam is conducted on a different day, questions they will change because the questions should not be leaked before the exam. But the type of questions is the same. So the best practice material is take the question papers of all subjects and start practicing for Part A section. This one can you please try? This was in another set of question paper. Another question paper. How many integers in the set 1, 2, 3 up to 100 have exactly 3 divisors? Previous question it was odd divisors. Here it is 3 divisors. All of you try. I'll come in a minute. Okay. Some of you got an answer. Let's see whether it is right. How many integers have exactly 3 divisors? Odd divisors, for that it should be a perfect square now. So from this list only we need to now filter, because 3 is an odd number now. So 3 divisors means it should be odd divisor only. So how many of them have 3 divisors? So as you know, in the last class of prime number composite number idea when it was taught, prime numbers also have 2 factors. Yeah, 2 divisors. So every number except 1 have at least 2 divisors now. So 3 divisor means by default 1 and that number are divisors. Other than that, one more divisor only. That divisor should be the square root of the number na. That means square root should not be factorized anymore. For example, look at 16. What is the problem with 16? 1 into 16 is 16. 1 chocolate given to 16 people is possible na. 2 into 8 is 16. 2 chocolates given to 8 people is possible na. No reminder there. You will get 16 chocolates completed. 4 into 4 is 16. So 4 is also a factor. So what is the problem here? The square root of 16, 4 can again be divided as 2 into 2. That is why this 2 into 4, 8 is another factor. This 2 is another factor. That is how more than 3 factors are coming. So if you don't want more than 3 factors, the square root of the number should be a prime number so that it cannot be factorized anymore. Prime factorized anymore. Square root should be a prime number means the number should be square of a prime number, right? The number should be square of a prime number. Square of a prime number, this is 1 square up to 10 square. That are the numbers which have odd divisors we already discussed in the previous question. Among that, prime number square perfect square will be 2 square, 3 square, 5 square, 7 square only na. In the previous question we discussed 1 square up to 10 square is these numbers. Among that you have to take only prime numbers square. Prime numbers from 1 to 10 are 2, 3, 5, 7 only. 2, 3, 5, 7. So square of 2, 3, 5, 7 will be the numbers we are searching for. So that is why 4 is the answer. Is it clear, all of you? Please respond. Wonderful question it was, right? And if you know the concept clearly, this is a very interesting and easy question. So now the idea of test of divisibility very fast we will discuss. That also indirectly, not only for this chapter, for upcoming chapters also it is needed. In 5 minutes very fast we will discuss test of divisibility of numbers. How to check a number is divisible by 2, 4 or 8. These 3 are easy. To just check the last digit. If the last 1 digit is a multiple of 2, the number is also a multiple of 2. Multiple of 2 means divisible by 2. Both are same. 2056 last digit is even number, so it is multiple of 2. So 2056 is a multiple of 2. For last multiple of 4, last 2 digit 56 should be a multiple of 4. That digit group should be a multiple of 4. 56 is a multiple of 4. 40 is a multiple of 4. 44, 48, 52, 56, 60, etc. are multiples of 4. So 56 is multiple of 4. So 2056 is also multiple of 4. And multiple of 8, to check it, last 3 digits should be a multiple of 8. 2056, 0, 56. That is 56. 56 is a multiple of 8. So 2056 is also a multiple of 8. All of you clear? In school days you have learned this. I am just reminding you because this is important in other chapters also. Then divisibility of 0 and 5 and 10, all of you remember, right? Last digit 0, then number is a multiple of 10. Last digit 5 or 0, number is a multiple of 5. Clear? Then divisibility test of 3, 9, 6 are also easy. Sum of digit should be a multiple of 3 for the number to be a multiple of 3. Sum of digit should be a multiple of 3 for the number to be a multiple of 3. And sum of digit should be a multiple of 9 for the number to be multiple of 9. 729, 7 plus 2 plus 9 is 18. 18 is a multiple of 9, so the number is also a multiple of 9. And how to check the divisibility of 6? There is no separate method for 6, but 6 can be prime factorized as 2 and 3. Na? So if the number is divisible by 2 and 3, then the number is divisible by 6. Both divisibility conditions you should check. How to check a number is divisible by 2? it should be an even number. That way you can say na. And if the digit sum is multiple of 3, the number is divisible by 3 also. Both these conditions are satisfied for 216. That is why it is a multiple of 6. Is it clear, all of you? Please respond. This is clear, all of you. And divisibility of 7 and 11 is little tricky. Very fast I will explain. 175, whether it is divisible by 7, how to check it. Take the last digit, double the last digit, 5 last digit, so double is 10. Subtract it from the remaining digit group. Remaining digit group means avoiding 5. Remaining is 17. Na? 17 minus double of 5. 17 minus 10, 7. 7 is a multiple of 7, so 175 is also a multiple of 7. Is it clear, all of you? I have explained this, and this flashcard we have provided in the Telegram group. You can check there. And daily we are now posting one flashcard and posting quiz related to those flashcard in Telegram group, Telegram channel. You can check out that in the description of the video. You can find the link of that also. So divisibility by 11, how to check it? Odd position numbers you have to add. 1 and 4 are the odd position numbers here. 3 and 2 you have to add. 3 plus 2 is 5. Subtracting these two, 5 minus 5 is 0. If that subtraction gives you a multiple of 11, then the number is also a multiple of 11. This subtraction is 0. 0 is a multiple of 11. So the number is also a multiple of 11. Is it clear? So that is how you can check it. And you should know the idea of LCM and HCF. In this flashcard I have provided it. Those of you have forgotten LCM HCF idea, check out these examples in the study material. We will add these content so that you can check this out. Properties related to LCM HCF also. I'll just show you 1 or 2 examples very fast. In school days you have learned a repeated division method for HCF and GCD are the same. Highest common factor, greatest common divisor. 15 and 36, if you want to find highest common factor or greatest common divisor, prime factorization you do, but simultaneously 15 and 36, find the common factor of 15 and 36. It is 3. Dividing by 3 you will get 5 and 12. There are no other common factors. Yeah, in the last class comment section someone was asking what are co-prime numbers. 5 and 12 are co-prime numbers because there is no other common common factor other than 1 among 5 and 12. That is why they are co-prime numbers. Till you get co-prime numbers, you have to repeat this process. So you already got co-prime numbers, so you cannot divide it anymore by any other common factors. Then HCF will be this value only, 3. That is the HCF. Is it clear? Now the same thing, how to find LCM, I will tell you fast. 15 and 36, same way you do you don't have to do, I already have shown you here now. So that is 3 is the common factor. Write that 3 into, now these co-prime numbers, 5 and 12, multiply that also. 5 into 12, 5 into 12, 60 into 3, 180 will be the LCM. Did you understand? In school days you have learned this, but in case you have forgotten, I am trying to make you ready for any chapter. All of you clear? Please respond. That is how you can find, that is one of the ways of finding LCM and HCF. So these extra questions as homework, please try it. And this is also a question related to the test of divisibility idea we have discussed. Okay, so as this is the 5th lecture, I'd like to hear from all of you the feedbacks that you have for this course also. Is this course useful for all of you? Do let us know in the chat section and in the comment section also. Yeah, definitely we need a little motivation daily to come daily at 8:30 p.m. because we are setting aside many of our commitments to not break this stream of classes daily. So keep motivating us. So if there is a two-way communication, always will be motivated. That is how every company or every institution also, there will be someone or the other, so that people are agile or people are enthusiastic. So we educators also needs that enthusiasm, and for us, you people are actually our motivation to stay motivated. So do motivate us, do encourage us, so that we can, yeah, to be frank, YouTube is a platform that is good for those people who are running a big channel. But to be frank, currently this channel is in its starting phase only. So the monetary aspect is negligible, to be frank. So the monetary aspect is not what is guiding us to conduct this. So definitely what is guiding us to conduct this is the to be frank, we like teaching, as Jesse sir also was mentioning in the last class. We like teaching, we want to do that, but every educator or every teacher will be happy when there is a big crowd in front of them. Their enthusiasm will be the next level, whether it is classroom coaching or in the online coaching. So do motivate us, do encourage us, do let more people know about these initiatives if you feel this is useful. So take an effort. Don't think that someone else will take an effort to spread the word. Take an effort so that more people can come. If you feel this is a genuine initiative that is to help more people, do tell to more people, do invite more people to these initiatives. We are planning for many things in the future, very near future itself. We are planning many things. Last day we were discussing, many of you like the way that we are presenting things so that you can understand even very simple aspects in a practical way. So we are thinking about starting a separate series also for that. That is what I asked, whether you want to like a separate session on infinity, or in separate session on pi, separate session on the fun stuffs in math, so that you will always love to learn maths more and more. That will definitely inspire us to do aptitude section also better, because once you love maths, this section also will become very simple. So that's it. Yes, Aishwarya, in Telegram we will be providing the study material, or in this channel itself in some time you will get the study material link also. In the comment section also you can find it. I think let's conclude here. So hope the session was useful. So as I told, this is a holistic course where the learning will be complete if you use all the resources. So this course you can check out. This is where we discuss more previous year questions topic by topic, and all previous year questions. If you want to see more questions practice daily, follow this playlist, CSIR-NET Part A previous year questions. And for GATE also, if you are preparing, this is the comprehensive full-length free course for GATE General Aptitude 2024. And in case you are preparing, or any of your friends are preparing for UPSC exam, this is a UPSC CSAT playlist. And if you want to learn about speed maths and how Vedic maths or speed maths will help you to improve your speed of calculation, and how Vedic maths and Western maths are connected to each other, you can check out the series. And the mathematics series, we are planning to come up with more content. So you can check out the content already there, and we are coming up with more content in the very near future. As I told, keep supporting the initiatives by educators if you feel that that is good for you and good for more people, and that is a genuine effort that educator is making. Keep supporting it. It is not about us only. I am telling about any educator taking an extra effort for you. Please support that educator. Nowadays many educators are actually confused whether students will support them or not. So they also need your support. So keep supporting if you feel that someone is doing good, whether it is educator or whether it is anyone in the society. If you feel someone is trying to make a change and that change is good for the society, keep supporting that people, or supporting them, so that the society will be also be better very soon, or there will be bigger changes happening. Okay, so that's it. Let's conclude. Thank you all of you. Take care all of you. WhatsApp group you can be part of. In the description of the video you can see the link of how to join it, or you can text to this number. Thank you. Take care. Bye bye. Have a good night.